Hey everybody, I'm Professor Hanks and welcome to Algorithm Engineering. I've got a short presentation that introduces really the syllabus, the resources are available, talks a little bit about the class, and then I have another intro video that really starts to intro the concepts that we'll learn in the class. So this is much more administrative, and I'll kind of give you an overview of the projects, the assignments, grading policies, the resources we'll use, and so forth. So welcome to Algorithm Engineering. I like to use that term because it's really a process that we're going to learn here about how to develop algorithms, and it could apply to deep learning or statistics or linear regression even. So let's go ahead and give an intro to the class and a little bit of overview of what is expected. So really high level comment here, the 21st century is going to be about algorithms. So really software has become so abstracted, and it's even becoming more abstracted so it's easier to use. So it's less about writing the low level code of a neural network and more about how do we engineer an application solution. And my example here is 35 years ago when I was in college, we learned how to program and develop from scratch fast Fourier transform algorithm. So that's changed over the years. Really today you use an FFT as a tool, and you learned the constraints, the Nyquist theorem of where it can be used, sampling constraints and so forth, and use it in applications. Machine learning and neural nets is moving in that direction. Just a few years ago, the details of the inner workings of a neural net were coded in classes. Now it's been abstracted so that we can really focus on the problem, and getting the data and engineering the features in the data become the challenge to solving problems. And that's what we hope to learn about in this class. So just a quick review, like deep learning on one slide, and we'll go into some details in the concept video about what's the difference between deep learning, machine learning, artificial intelligence, and kind of some nomenclature there. That's also covered in chapter 1 of your reference books that I'll be talking about in just a minute. But some things to appreciate. Today we're using deep learning for facial recognition. It's quite controversial. Many states have outlawed the use of facial recognition for biometrics. It's been used in image classification. Just a few years ago, there was a lot of news about being able to differentiate between dogs and cats. Google had come up with an algorithm to do that. Today, it's really nearly the hello world or getting started type application in machine learning just in a few years. So you can see a long list here. This class, we're going to focus on biomedical applications. I don't have that as a strict requirement for your project that you will develop yourself. The preference is for biomedical applications. What I'm interested in is you finding a problem that you're passionate about, because that's where I think the best learning occurs. So the real challenge is, can you really solve these problems with the tools that we have today, and can you get access to the data? And so we'll spend a lot of time looking at applications and trying to decide if it's a good application for machine learning, and can we get the data? That becomes ultimately the challenge, because to really implement one of these deep learning applications, you need a lot of data, on the orders of thousands of images for an image classification application. Why now? Also is the hardware, general purpose units. The gaming industry has created this hardware called a GPU, graphical processing unit, and it really works well on vectorized parallel data, and neural networks have an architecture that allow you to do parallel processing similar to what would occur on graphics video. So the cost of hardware has really come down, and you can actually use Google Colabs, which offers a free GPU support, so we can load our models up onto Google Colabs, which is a part of Google Drive, and execute them really free of charge on a GPU. So this speeds up the training to create the model, and we'll show how to do that in our class as well. So a lot of amazing things in this time period that are going on, and we're really, in some ways, at the beginning stage of this. The applications today are narrowly focused on a specific application. It's called narrow AI, and what we'll probably see in the next 10 to 15 years is really general AI, where possibly several of these models are combined together in a clever way so that you have general purpose intelligence. Today, when you ask Alexa to give me a strategy, at my home, we play Catan, which is a strategy game. And if you ask Alexa to give you a strategy for playing Catan, it refers you to a website. So Alexa is not necessarily giving you a strategy, but it's parsing natural language and directing you to a website. So it's an element, it's a very narrow part of AI, but it's not giving you strategy, for example. That's a very human characteristic. So we'll talk a lot about that in the class as well. So you may ask yourself, how much coding do you need to know to get through this class? I teach Python. I've been in the software industry for nearly 30 years. I think coding is such an important skill and tool to have. Bottom line though, today's tools are very abstracted from machine learning. In this model, I'm using Keras and TensorFlow, and really there's 6 lines of code here to be able to create a model that can do handwriting recognition. I've got there a number of input images of 5. It's a handwriting image. Our model here, our neural network, will then classify that and say the output is a 5 with nearly 90% confidence. So each of these elements that I've got here, the 6 elements, we will cover this, and so that you know the details of how to create the model from, what are the layers in the model, a dense layer, convolution neural network, what's the type of activation function you will use, rectified linear unit, softmax in this example, how to set up training data, test image data. All of that we'll cover in the class in detail so you get the underlying concepts so that you can build your own models. And then ultimately, you could even store these models weights and then reuse them on a phone or another piece of hardware. So the training is what really is expensive and takes time, but once we have the model created, we can deploy it on different form factors, and we'll do that in class as well. We'll deploy on a small piece of hardware from NVIDIA called the Jetson GPU. All right, so I have, if you haven't coded a lot in the past, I've created some walk-along videos that covers the basic concepts of neural networks. I've got one on forward propagation, backward propagation, and really there's 3 or 4 videos that you could go through, and I've written the example so that you could code along with me, and so you can come up to speed in Python, and really Jupyter Notebooks is what I use as the core software platform, which is based on Python for the class. So you need to be knowledgeable about how to program, the fundamental building blocks of programming, how to work with manipulate arrays, all and tensors really, and machine learning. I go over that so that you can come back up to speed. But if you're at 0, I think this class will be challenged for you. But if you have some experience, I think the follow along code videos that I've created so that you can follow along and come up to speed quickly will really help you. All right, just a little bit about me so that you have some context, and I hope to learn about you as well during the class. I'm not your typical academic in that I've come from industry. I'm a professor of practice. I was at National Instruments for 24 years, started out there early stages, a few employees, and we grew to nearly 8,000 employees, and as a public company at this time, we went public in the 90s, and I was at National Instruments until 2014. I was a professor of practice at A&M from 2014 to 16, and I've recently come back. I've managed R&D groups. I have hardware and software, and have been R&D manager at a semiconductor company. So developing sensor technology and integrating that with algorithms is really my passion. For fun, I've developed a lot of Android applications in the past. Over 1 million users, had 2 top 10 Android applications at one time. Probably learned 10 programming languages in my career. I have degrees from both A&M and UT, and I really value the combination of technical skills to be able to communicate that well, and I hope that can inspire you to improve your communication skills as well. I've started companies, I have 2 children, both of them are engineers or computer scientists, and I really like the podcaster Tim Ferriss. If you get a chance to check him out, check that out as well. Okay, I hope to learn about you as well this semester. From what we'll be learning in the class, we'll really spend some time understanding neural networks and the building blocks of machine learning. And then how do we apply the basic machine learning algorithms to real world problems, and then really spend a lot of time trying to defining and augmenting and working with data so that we can solve the problems. That really is a bottleneck today, is how can we get our hands on the data, how do we process the data so that we can input it into a model and create a generalized model. And generalization is the goal. You can overtrain a model so that it only works on the data that you give it, and that's not the goal. We want to train our model on the data that we've given it, and then give it new data that it's never seen before and have it be accurate, and that's called generalization. So we will talk a lot about the constraints and limitations of machine learning algorithms today, and then really I hope that you come out of this class with a real appreciation and passion for developing applications. You're at the beginning of a revolution, I believe, and understanding how AI can be implemented is going to be important in your career in the future. I've selected this Deep Learning with Python book by Francois Chollet. I hope that I've pronounced his name right. I hope I've done him justice. It's been in use for a couple of years now. There's a lot of examples online that you can look at, and the coding examples in the chapters are really straightforward. You can basically use those to develop an applications, and that's what we'll do. I have this mentality that you have to start off. You have like Picasso basically said, you have to start out copying artists, and then when you become a master, you basically have steal from a great master. Steal, they don't copy. So you have to be able to start developing code easily and quickly, and then we'll ramp you up to speed so that you can create something your own. And I think this book does that for you. I use this second book, this O'Reilly book, Hands-on Machine Learning, as a reference, more of a reference. It's more detailed on some more advanced topics, and we'll cover those later in the semester. So it's kind of the second book. It is highly rated as well. And then I've suggested hardware. We will deploy a solution, and I don't believe I've got on the syllabus. I'll try to add this here as an optional piece as a camera. It's $29 or $30 to get the camera, and it'll be interesting to deploy a solution, an image processing solution, onto the Jetson Nano GPU hardware. And we don't need one of those for every student. If you want to get it, that's great. We need one for every team. So you'll be asked to group into teams, and then we'll deploy an application onto the hardware. Okay, so we've touched on this. There's so much that's going on with deep learning, and the high-level message here is, line out is, the hardware is available, the software's been abstracted, data is available online through all these different resources, and so it's a good time for you to understand machine learning. So a little bit about the grading. We'll have a few homeworks and assignments. This is a graduate level course, so I'm not going to really be on top of you with a lot of assignments. I expect you to cover the exercises and that we talk about in the lectures, and be prepared for the lectures. I'm going to really think of this as an asynchronous course where I release the lecture, and then we'll use the times Monday, Wednesday, Friday at noon as really office hours. I'll often cover the assignment material, the exercises that I asked you to cover, and the reading, and then review what was in the video lectures, and so that you get a further understanding. And my hope is that you come to the office hours with questions, and really it's a dialogue between myself and the class. So I'm hoping we can make that very interactive. So really, assignments, Project 1 and Project 2, there's no exams that I have scheduled for the class. The Project 2 will be a team project, up to 3 people on the project. So you'll have to define your project and collect the data, and then create the model, and then report that out. All right, and so to get you thinking about the problems that can be solved today, the first assignment is a review article on applications in biomedical engineering. So you can see the rubric on what the deliverable is here. Go off and read this, select a raw article, and create a short video on that article. And what we'll end up doing is probably reviewing, showing a couple of these in class, or make that an assignment to view the presentations that you come up with. The goal here is to understand what types of problems are being solved today with machine learning, and to start introducing you to the language of machine learning and artificial intelligence, and so that you can land on an application that you're interested in and start developing that. Okay, for Project 1, we will all do the same project, and this will focus on cell classification. The classification problem really says, okay, I've got these 7 categories, and I present my model, my trained model with a new image in one of these categories, and it classifies it into those categories. And this is an interesting problem. It's basically a life cycle of a malaria parasite, and we're able to categorize the image based on where it is in the life cycle. And those are the 7 different categories to the right of the images. So have a data set here that we can use, so we don't have to go get the data. There's some challenges with it. It's unbalanced, so we don't have the same number of images in every classification, every category. And so that creates some challenges for us. So we'll work through that problem together, and that'll be your Project 1. Project 2 ideas. So this will be your you can either do this as independent project or with the team. And really the first 4 to 6 weeks here will be really trying to understand the fundamentals so that you can select a good project for the second half of the semester. There's a lot of resources. Kaggle.com is a resource for machine learning. There's 50,000 data sets, and hundreds of thousands of public Jupyter notebooks that you can use as a starting point. I particularly like the Stanford Machine Learning course. They've documented and we're going to follow a very similar format where they have the students write a paper and then post it in a PDF form. And there's hundreds of these projects up there, and I've picked 3 there that I liked from the Stanford course as an example. Mammograms, early detection of mammograms, using images from a baby monitor, senior healthcare. The list of applications goes on and on. And there's hundreds of these at that cs231n.stanford.edu website. We will have an early milestone proposal that's be due for you and your team, and really see the final rubric for the deliverables. But it's a few pages long, and you'll identify your team, and you'll write up, hey, here's the problem statement, the background technology, here's what I expect, here's how I'm going to get the data, here's the high-level flow chart of how my program is going to work, and then here are the roles of each of the team members. And that'll be due about halfway through the semester. And then my goal for this class is to get you through kind of this lower level of the pyramid here in the first few weeks, so you understand the basics of neural networks, machine learning, then project 1 gets you to this point where you can apply what you've learned, you can analyze, and then ultimately with project 2, it's all about, can you take what you've learned and create something new? And so that's the goal for the class, is to get you to the top of the pyramid there, where you have created something that's new. So if you really want to make an A in this class, I think this is how you do it. You get the new concept. I have a lecture video that you follow. You can follow along the coding in Spider or Jupyter Notebook. Use all kinds of online references. YouTube has literally hundreds of videos on machine learning concepts. Andrew Ng from Stanford, 3 brown, 1 blue, sent decks. There's so many different online references. I reference those in a lot of the applicable videos in the reference notes for each week on Canvas. Okay, so you can go take a look at those. Assignments. I have a lot of questions that I put into the Jupyter Notebook source code, and then include the links and references so that you can go find them yourself. So I think you need to code probably a couple of hours a week, so just to keep up. So that's the kind of expectation, is that you're going to be doing some kind of coding, developing an application, probably 2 or 3 hours a week. I'm going to not have all of the lecture time office hours, where we will have we won't use the full hour, so we may have a topic that we'll cover for 15 to 30 minutes, and then you'll have another 30 minutes to do your coding or develop your application. I ask you to come to the office hours, done the work for the past lecture, and come with a couple of questions. And we'll hold our lecture or office hours on Zoom. So I developed the course so it's asynchronous. You have the videos, you have the assignments, and I'm hoping that you come to office hours and find value there. For my Python class, the students that came to the office hours are the ones that really got the material, because it was an interactive dialogue about how to solve the problems. Those are the students that tended to make the highest grades in the class, were the ones that were coming to the office hours and lectures. So I encourage you to do that. Okay, meeting times. We will meet from noon to 1 p.m. for our lecture office hours. I'm really not saying it's mandatory. I'm just saying that you really learn the material if you come to the office hours, because I'll review what was on the videos, talk a little bit about the next assignment or next concept that we're covering, and I think that'll be useful. And my hope is that we can turn this into a real exciting course for you, where it may be one of the best, my aspirational goal is to make this the most interesting class that you've had in your academic career. And I think I need you to help me do that. I need you to be prepared and be present at the office hours and ask questions. And this is a very dynamic field. I may not know all the answers, but I'll do my best to go off and find the answers and come back and present those to the class, or help you find them if that's an option as well. So I ask you also to schedule a meeting time. If you have a team that you're putting together, or if you have an individual question, please send me a calendar invite. It can be during the latter part of the office hours. So I don't expect our office hours to always go an hour. And if I think I can fit it into that noon hour, I'll schedule around 12:45 for a meeting. All right, so watch the video lectures before the assignment and come prepared. Be present. Also, I'm not here to frustrate you. Don't get frustrated. I sincerely hope to inspire you to learn about machine learning and enjoy programming. If you have a problem or you need clarity on a question, please ask for help. And here's how to ask for help. A good way to do that is explain your problem, tell me the 1 or 2 things you have tried. If you've got an error code or you're seeing a problem over and over, screen capture that and send it to me. So, oh, this is not working is usually not helpful if that's all you're sending me a note on. Please go one step further and say, hey, I tried these 2 things. Here's my challenge. So that would be appreciated. Okay. And then here's my contact information. There is a TA for the class, Nicholas Moretta. I think his last name, Nicholas's last name means sauce in Spanish. So he's Nicholas Moretta, and Moretta means sauce. So I love that. So please feel free to reach out to us. And if you have any questions, I'm looking forward to getting started on the semester. Okay, and finally here, I've got an inspirational reading. If you just like to do kind of reading on the weekends, I really like this book called Superintelligence. It's recommended by a lot of really smart people, Bill Gates, Elon Musk, and so forth. It kind of maps out where we're at in machine learning today and where it could go, and some of the ramifications of superintelligence. And superintelligence meaning if you get general human intelligence at some point, and the learning system learns how to learn, then you get an exponential effect and a runaway effect. And so that's what superintelligence is. So it's a very interesting reading. We'll talk a little bit more about this in the concepts video that I have next. That's the intro to the class from the concept side. All right, thanks again. We'll talk to you soon.